In this video, we're going to start topic 2.10, finding the derivatives of tangent, cotangent, secant, and cosecant functions. So our essential question is, how do you take the derivative of tangent, cotangent, secant, or cosecant? And I can take the derivative of tangent, cotangent, secant, and cosecant. So we didn't do this earlier. We did earlier. We did do the derivative of sine and the derivative of cosine, which we know is the derivative of sine is cosine, the derivative of cosine is negative sine. But we never did the derivatives of the other four. And they do exist. And the reason we hadn't done them yet is because I wanted to be able to prove to you what the derivatives were. We're only going to do proof of one, but we need the quotient rule to be able to do that proof. So that's why we held off, because we didn't have the quotient rule. So you can see in this chart here what the derivatives are. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant x tangent x, and the derivative of cosecant is negative cosecant cotangent. You'll notice that when we start with a C, notice all of those ones are negative in front. So that's kind of a pattern. Also notice that tangents and secants go really well together, just like in our Pythagorean identities, and cotangents and cosecants go well together. So our activity is to prove that the derivative of the tangent of x is actually equal to secant squared. So let's go ahead and try that. So, I lost one now. Okay, so I'm going to rewrite the derivative there. So we've got d of dx of the tangent of x, and that's the same thing as saying the derivative of, and we know that tangent by the quotient identity is sine x over cosine x. So that was one of our trig identities. So I'm going to go ahead and identify my green function and identify my red function and my green function. I'm going to take this derivative. So dy dx equals the derivative of the reds. The derivative of the red would be cosine x. Keep the green the way it is, cosine x. And then I'm going to subtract keep the red the way it is, so sine x. And then the derivative of the green is negative sine x. And then we are all over the green squared. All right, I'm going to simplify this. So double negative is going to go positive. So cosine times cosine would be cosine squared x, plus sine times sine would be sine squared x, all over cosine squared x. Now, this numerator looks awfully familiar. So do you remember the Pythagorean identity? Sine squared plus cosine squared equals 1. Well, that's what I have. It's just written in the backwards order. So I know that I can replace sine squared plus cosine squared with the number 1. So that's what I'm going to do. So I got 1 over cosine squared x. Now, I'm not going to leave, we typically in trig and in calculus will not leave it as 1 over something. So we're going to use our reciprocal identity to simplify that. And we know 1 over cosine squared would be the same as secant squared x. So there we go. We did prove that the derivative of tangent is in fact secant squared.